The next set of questions asks us to solve systems of equations. The first is 3x plus 2y equals 1, and 3x minus 2y equals 2. Now, the way I've chosen these numbers, there's a trick we can pull. Because I have two different equations, this left-hand side is equal to this right-hand side. This left-hand side is equal to this right-hand side. I can actually add these equations to each other. On the right-hand side, I just say that 1 plus 2 equals 3. On the left-hand side, I say that 3x plus 3x equals 6x. 2y minus 2y equals 0. Well, that cleans up things considerably. Now we can say that x equals 1/2. We're halfway done. If you like, we can try the same trick again, but with subtraction instead of addition. I will say that 1 minus 2 is minus 1. 2y minus negative 2y is 4y. And 3x minus 3x equals 0. So once again, I just do a little bit of division, and I find that y has to be negative 1/4. This is a really nice way to be working as long as the numbers play well with each other. They don't always. Let's take a look at the second one of these problems, which we'll have to use a little bit more elbow grease. So not only are the coefficients less friendly in this problem, we've changed our variables, and we are now trying to solve for variables a and b. The equations we have are 4a plus 3b equals 0, 7a plus 2b equals 10. For this, I want to take one of these equations and use it to solve for one of the variables or the other. And just because it's first, I'm going to start with this equation on the top. Let's solve for a in the equation 4a plus 3b equals 0. I'm first going to subtract 3b to the right-hand side of that equation, which tells me that 4 times a equals negative 3 times b. And if I divide both sides by 4, that gives me a formula for a. A is going to be the number which is negative 3/4 times b. The benefit to this approach is now I can take this formula and replace the a in the other equation to see what I get. So I'm going to say that 7 times minus 3/4 b plus 2 times b is equal to 10. All right. So since I have a fraction here, I'm going to multiply everything on both sides of the equations by 4. The reason I'm doing this is just to clear that denominator. On the right-hand side, 10 times 4 is 40. Good. On the left-hand side, I have 7 times minus 3 times b. And this is going to be added to 8 times b. So here, I've canceled the denominator, but I also had to multiply the 4 onto the 2b. I remember that 7 times a positive 3 is positive 21, so 7 times a negative 3 must be negative 21 times b, plus 8 times b, and this is all equal to 40. So then if I have minus 21 copies of b and plus 8 copies of b, I'm going to get minus 13b. Sometimes I have an easier time thinking about these things if I pretend that this is 21 take away 8, and remembering that my answer is supposed to be negative because the negative number is the larger magnitude that I'm working with. So the formula I get is that negative 13 times b equals 40, or that b equals 40 divided by negative 13. And if this is the value of b, then a has to be minus 3/4 times that same number. Let me write it as minus 40 divided by 13. Since 40 is divisible by 4, I can simplify this. The numerator is going to be 3 times 4, which is 12. The denominator is going to be 1 times 13, which is 13. And this had better be a positive number because it's the product of two negative numbers. The end.